Okay, so let's get started. So, so today we're going to be looking at Amazon EMR um, and how to simplify running Presto and Alluxio in this environment, and kind of why you would want to in the first place. So we'll kind of dig into a little bit of each one of these to give you some context about what Amazon EMR is. I think Presto is fairly well known, but we'll touch on that as we go. And of course, what Alluxio is and why you would even want to run such a combination in your environment. So a little bit about Alluxio, just from a community standpoint, from the first place. It is a open source project that got its start as a PhD thesis at UC Berkeley's AMP Lab. And it was actually originally got its start as the off-heap persistence layer for Apache Spark. That was probably somewhere in Spark 1.0. And since then, it's grown quite a bit and expanded in terms of its capabilities of what it can do. And from a community side, it's an Apache 2.0 licensed project with 1,000 plus contributors, and all helping to grow this piece of software as well as the community for something that is incredibly useful in these environments around big data engineering and hybrid cloud environments. As a quick introduction to Amazon EMR, EMR is Amazon's offering for Elastic MapReduce. And so what it is it is a way that is provided from AWS as kind of a service, if you will, to easily provision, manage, configure many of the things in the Hadoop ecosystem. So what you have availability for are just about anything that you would find in a typical Cloudera deployment or Hortonworks deployment. So Apache Spark, access to HDFS, access to Presto, Hive, HCatalog, and any number of other things. And so what it does is it allows you to have a very, very easy way to kind of configure and onboard Hadoop services in AWS. And so it manages most of the work for you. One of the things that's kind of unique about it is, I guess, unique from a Hadoop standpoint, is that it's very elastic and flexible. And so similar to a number of other AWS technologies, it has the concepts that are native to cloud of being able to kind of resize and right-size the environment. And so you can actually have a Hadoop cluster that's running Spark and Presto and all of these different things, and have it resizable based on whatever parameters that you want. EMR also comes with something called EMR-FS. And what that's designed to do is allow you to have a consistent view into S3. EMR-FS provides what I think of as a shim layer, if you will, to give you HDFS-like access to S3. It allows you to have consistency in terms of read, and write type operations, as well as an easier onboarding to encryption as well. So that's a high level for EMR. We'll talk about some of the sample Alluxio use cases, right? Some of the ones that what we're known for and what you might find as a useful thing for using Alluxio in this combination. So the first one that we're going to look at is accelerating big data frameworks in the public cloud. And so if we take a look at this, in this example, it's probably not the best example for a Presto webinar, but here we have Apache Spark and Alluxio, and here they're running in combination to accelerate work for data that is coming off S3. And we'll look at how Alluxio is able to do that, but just at a high level, we have a number of customers that are using Alluxio in this configuration, whether it be Amazon EMR, in Google Dataproc, or Microsoft Azure, to speed up some of these frameworks where they are trying to get access to data that lives on an object store in that particular cloud. We also have other use cases where people are trying to burst their big data workloads in hybrid cloud environments. And really what that means is, we have a lot of customers where they've got a data warehouse that lives in their data center or on premise, and they've got a lot of really critical data in there, a lot of processes that are tied to generating or filtering or cleansing that data. And that data center is out of capacity, right? And the easiest thing for them to do is to leverage cloud for what it's great for. It's great for scaling out compute and compute resources, whether that's CPU or GPU. And so a number of people will want to take advantage of these capabilities, but the topology itself has some constraints, particularly the network latency and the network bandwidth for actually transferring these big data workloads back and forth. And so one of the things that Alluxio is typically used for is making these hybrid configurations an efficient and scalable solution. And it does this by allowing seamless access to the data and allowing you to cache the data in the cloud as it's accessed and have things be user-driven by the application. That way a data engineer is not responsible for manually dis-CPing all of the data or some of the data up in the cloud and find out you're missing something, right? And so that's another use case. The last thing that is typically common as a use case for Alluxio is dramatically speeding up big data on object store in the data center. And so we work with a number of customers that have shifted off their data warehouse from Hadoop or Teradata, and now they're leveraging a object store of some kind. And so we have a couple of them laid out here, but in the same way that Alluxio helps to accelerate object stores in the cloud, it also does the exact same thing if you're using something that's got an S3 interface that's not running in AWS. And so that applies to any number of things. Okay. So now we get into a little bit about what it is about Alluxio that allows it to actually do this. And so part of it is a data locality layer with intelligent multi-tiering. And really what this gives you is the ability to have these big data environments where you have a warehouse that's got hundreds of terabytes, if not petabytes of data, and provide seamless access to that while also giving your application performance like the data is local. And the way it does it is by actually making that data local. So the Alluxio workers will run in a cluster, and they'll typically run co-located with a piece of technology that we're enabling. And so in this case, this example, we're working with Presto, and the Alluxio worker would be co-located with that Presto worker. And you would configure Alluxio to leverage the memory, the SSD, the HDD, pretty much whatever it is that you have remaining and available for Alluxio to leverage so that it can cache some of the data that's coming from the warehouse. Now, in this case, if Presto asked for, the last month's worth of data, that would typically map to a partition, which maps to a folder that lives somewhere on S3. That request would go through Alluxio. Alluxio would see that it does not have that piece of data, and what it would do is it would pull it down from S3, cache it locally somewhere in this tier, and then the next time a query is requesting the same partition or piece of data, that data is local and it can be serviced locally from whatever medium is appropriate. And so this is great for ad hoc workloads because they're typically very iterative, I can't say that word, in nature, where you are firing off an initial query and then tuning that query after you get your initial result set until you find the answers that you're looking for. And so this is great because that initial query will run at the same speed that it would normally run, fetching data from S3, but the subsequent queries would run much, much faster since the data is being read and buffered transparently to the application from Alluxio, which is sitting local to that machine. So it's a great way to gain additional performance. Additionally, one of the capabilities with Alluxio is the ability to provide a data elasticity, and it does this via Unified Namespace. And really what that means is we're able to essentially provide a logical file system hierarchy to the application, in this case Presto, And underneath that logical file system hierarchy, it actually maps to physical file systems that we mount and present seamlessly to the application. Now, in this case, you can actually configure Alluxio in a couple different ways. I have it right now configured in this example to mount a HDFS warehouse at its root mount point. And you can actually see here that I actually have a secondary mount point. We call this a nested mount point that's pointing to an S3 bucket that's mounted under /data. So for my Presto application, it doesn't really have to care, if a given piece of data lives on, an S3 bucket, a Google Cloud Storage, an Azure Blob Store, or, the warehouse on-prem. All it knows is it's connecting to, an Alluxio cluster, and Alluxio is presenting it this data. And so it's great because it allows you to, in kind of a centralized manner, manage the authorization, the authentication, and the connectivity to these different sites, as opposed to having to do it at every single application layer. Okay, so if we start looking into past some of the context, we start looking into some of the actual prerequisites for running this solution. Since we're focused on EMR today, we'll just go over some of the things that you'll need. They're all fairly simple. If you have an Amazon account that you have access to, most of this can be, it's pretty simple to provide. But obviously, you want to make sure that your account is set up with the default EMR roles. You want to make sure that you have access to an S3 bucket that you can read and write from. You want to make sure that you have your SSH key pairs for EC2. You want to make sure that you have the AWS CLI installed. And then from there, what you're looking at is leveraging some of the Bootstrap scripts from Alluxio. Bootstrap is kind of an interesting mechanism that AWS provides for EMR. And essentially what it allows you to do is it allows you to bootstrap additional services into this Elastic MapReduce Hadoop environment. And so in this case, it allows you to easily tie in an Alluxio installation into your EMR provisioning framework. Okay. So EMR provides a number of things, but what it allows you to do that we leverage is it allows us to tie into some of the configuration files at the Hadoop level. And so what we're doing here is we can actually specify configurations in some of the core Hadoop and Hive configuration files so that they can actually work with Alluxio if need be. In terms of the Bootstrap actions, this is kind of an example of some of them, right? And what we're looking at here is how you would actually go about creating an EMR cluster, specifying, the specific types of instances, the number of them, the applications you'd like to use, and additional Bootstrap actions. And this is kind of where Alluxio falls into this, right? And so with this simple command through the AWS CLI, you can actually deploy an entire Hadoop cluster running Presto, running Alluxio, without actually having to configure or manually provision, anything in this environment. In about 5 to 10 minutes, the thing will spawn up and you'll be able to start using it. Okay. In terms of Alluxio options, there are a couple, right, that you'll need to know about. You'll typically want to know, like, some of the more basic things, right, like the specific type and number of instances that you'd like to leverage, the version of Alluxio that you'd like to run, the S3 bucket that you'd actually like to connect to, and a couple other things, right? But the options are fairly simple, and they're actually well spelled out in the documentation. After this presentation, we'll send out a link to this Presto, and it actually has all the links that you'd actually need to get started with this at the end in the appendix, and walk you through the installation if you're thinking about trying it on your own. Okay. So from there, once your environment's built up, there's a couple different steps for you to do to get up and running with actually starting to query using Presto some of the data that you might have. And so Presto allows you to, actually, I should say EMR allows you a number of different options for metastores. A metastore is just, exactly what it sounds like. It stores metadata about your data, right? And in the case of, a query framework like Presto, that metadata is simply, the databases, the schemas, the table definitions, all of those different things. And we can leverage things like Hive, which are provided in the EMR environment, or we can leverage things like AWS Glue, which is a metastore service that AWS provides for this service. And so what we're able to do is we're able to create table definitions in either. And one of the differences is the table definitions for Alluxio tables can take this format, Alluxio : ///. And what this tells the application is, instead of, hey, looking for a S3 URI for the location of this data, or instead of looking on HDFS, hey, instead look in Alluxio. Okay. Glue has some really interesting and really useful things. One of them is the crawler. And so the crawler is something that I found to be particularly useful. And so what it allows you to do is it allows you to export, let's say, a bunch of tables or a bunch of databases from your existing warehouse and load them onto S3. And once you've done that, you can actually point this crawler at that S3 location, and it'll actually crawl that location and fill out all the metadata for you for those table definitions, for those locations, all sorts of things, and pre-populate AWS Glue for you so that you can, copy over your, segments of your data warehouse or your entire data warehouse, have AWS crawl through it for you and automatically set up the metadata so that you can be up and running very quickly with this system. Okay. For leveraging Alluxio, there are a couple different ways. So the first thing that we're looking at here is two table definitions. I know it's not obvious. I should have included a little bit more of it, but it's hard to do that with any normal table definition fitting on the screen. But for right now, we're looking at a table definition for a table called item, and we're looking at it in two different ways. We're looking at it in the normal way, where S3 may have crawled Glue may have crawled my S3 bucket and seen that under the Alluxio Alex bucket, under UFS, TPCDS, test data, Parquet, under this gigantic path, I've got this table called item, and it's populated all the data for me, and it has the location as my S3 bucket, right? One of the ways that we used to integrate Alluxio in these environments beforehand was simply changing out the location of the table. And that's what you see underneath it. You see an Alluxio URI for the exact same table. And what this would tell Presto is, hey, instead of going directly through S3, go through Alluxio for that data request. And this was, I'd say, prior to late last year, how we would typically do things. And this mechanism was great because it offered additional performance for customers that were looking to use Alluxio. But this was offset by the fact that they actually had to either create or modify their existing table definitions so that they could actually leverage Alluxio in this environment. Now, we actually use a new feature we call Transparent URI. And what this allows us to do is define a file system implementation on the Hadoop side that tells Presto, hey, anytime you see this kind of scheme, go ahead and use this class to handle it. And in this example, I have mistakenly left in an HDFS implementation, but you would simply swap out HDFS with S3, and that would tell Presto every single time you see an S3 or HDFS URI to use the shim file system. And what the shim file system does is it handles the translation of this URI for you to an Alluxio URI. It looks for, in Alluxio, do I have this bucket mounted? And if so, I can convert that path to this path automatically for your application so that you can leave your metastore exactly as it is, without having to do any additional work other than providing this as a configuration during the Bootstrap. Okay. All right, so that was kind of the extent of our slides. Let's take a look at what this looks like on a live system. And so I think the first thing that we'll do is we'll show you kind of what is involved with actually firing this up. And so what I have here is my general notes. But if you take a look, this is kind of the command that you would actually use to fire up a cluster. And so in this case, what I'm doing is I'm saying, hey, I want to do a AWS EMR create cluster. I want to have 5 instances. They should be M5X large. The root volume is such. The applications that I'm going to leverage are Spark, Hive, and Presto. Here are some of the Bootstrap actions. Right? And this is literally all I need to do. And so if I copy and paste this, what this will let me do is kick off a cluster. And you can see here this cluster ID that was specified. That means everything was successful. When you run it from the command line, it's not super verbose about what happened, but what it's actually doing is it's kicking off a cluster and it's provisioning the EC2 instances. It's going through the Bootstrap process to install all of the Hadoop components as well as all the Alluxio components. Okay. So after it is set up, what you can actually do is you can actually SSH to the master node. In this case, I've already set up another cluster so that we don't have to wait the 10 or 15 minutes that it might take to boot up. And what I will do right now is show you kind of how you can go ahead and run these things, right? So what I have here is I have this set up with the original configuration. And so in this case, if I load Hive, I already have Glue and it's set up a database for me. And what I will do is we are going to use one of these table definitions that I have, and we are going to do a longer version of what I was showing you in the slides. Show, create. Okay. And so what we have here is one of the table definitions. And you can actually see here that it's got all these attributes for this table. I think the most important thing here is that it is showing you that the location of it is an Alluxio location, right? And so before we do that, let's actually, this is actually a fresh cluster that I fired up just prior to this demo. And so real quick, we'll actually show you what Alluxio looks like. And so here, what we can see first is we're going to run a report that shows us kind of what the state of this is. And you can see this has been up for about 2 hours. It's running the Alluxio version 2.12. It has a capacity of 5 workers in the cluster with 64 gig of memory capacity. And we have something like 36 gigabyte already loaded in our Alluxio tier storage. If I also run this, what you'll see is the mount points that Alluxio is using. And so you can see here that Alluxio has mounted this S3A Alluxio UFS bucket. So if I run the AWS commands to actually list this, you can see here that I've got, a number of folders in this bucket. I've got bin, I've got Bob, bootstrapping, a whole number of different things. And if I actually do the same thing in Alluxio, I can actually do it with a fsls/. What it will show me is the exact same thing, right? Because we've actually mounted this through Alluxio, and so Alluxio is going to provide seamless access to this S3 bucket. And I've actually configured this Alluxio system to have everything default owned by Hadoop, right? But what this allows us to do is have Presto seamlessly access this data. So what we are going to do is we are going to run Presto and we are actually going to tell it, we're going to use that database instance that we created before. And this database is actually filled with data from TPCDS. TPCDS is an industry standard benchmark for big data and database workloads. And the DS suite is I think the decision criteria. It's the closest thing that maps to big data workloads. And so we'll take one of the queries that comes with it. And you can see here, this is a rather large query. And TPCDS is comprised of both, obviously, the table definitions, the data sets, a way to generate the data sets, as well as specific queries to exercise the entire framework. But what we'll do now is we'll actually go and run it through Presto, which is actually hitting Alluxio, and see what happens. And so what this allows us to do is seamlessly run this through Alluxio, and we'll just wait for it to finish planning, and after it's planning, it will kick off work to the 4 Presto workers, which are going to fetch data from the 4 local Alluxio workers. So you can see it kicking off right now, and we'll just wait. If you can see here, the interesting stats, the ones that I typically look at, are the number of rows that have been processed, the rate at which they're processing. In this case, it's processing at around 7.5 million rows a second, which maps to 140-ish megabyte a second, and it's finished. And so what it's done right there is essentially queried a database with about 40 gigabyte of data that's stored on S3. That was cached in Alluxio. And what it allows it to do is query all that data like it's sitting local on those Presto nodes. Okay. So that was the demo. Last couple things here. More about Alluxio, again, than the overall solution. But, we have a very large number of community users and enterprise users that are leveraging Alluxio to see some of the benefits that we talked about today in terms of, speeding up these big data workloads in the cloud, or speeding up these big data workloads in hybrid cloud environments. Some very large clusters deployed. The cluster size is usually tied to the number of computes that we're working with. So if you had a 500 node Spark cluster and you had Alluxio workers installed co-located with those, you'd have a 500 node Alluxio cluster. So that's one very simple way to see why some of these clusters get as large as they are. In terms of additional resources, again, we'll be sending this out afterwards, but here's a number of links to get you started with running Presto and Alluxio, some of the things that we talked about, some of the top 5 performance tips for running the two together. And these are all useful links if you found this presentation interesting. So that was it. Let's take a break and see if there's any questions.
Thank you, Alex. That was a really interesting presentation. And here we have our first question. Can you run Alluxio as a standalone EMR cluster separate from the EMR Presto cluster?
Yeah, so that's a great question. So with EMR, Elastic MapReduce, there's a couple different types of ways that you might go about running it. And so people will run these as either ephemeral clusters, where the cluster is essentially spun up. It does a short bursty workload, and then it's spun down or killed completely. Others will run their EMR clusters as long-running clusters where they're always on and just waiting for jobs to get submitted to them. In the case of either of those, the answer is yes. You can run a standalone Alluxio cluster on its own that either of those EMR clusters can leverage. You can continue to leverage the EMR framework to simplify the provisioning of this, but this is actually especially useful in the case of the ephemeral clusters, right? So if you have an ephemeral cluster and you're spinning it up in that manner, part of the reason you're doing that is to optimize the number of hours that you're spinning up these instances so that they can do their work as quickly as they can, and then they shut off and you're not being billed for the time that they're sitting around. The thing Alluxio adds to this in this capability is in speeding up that workload, because what it allows you to do is provide a much faster layer of access compared to accessing the warehouse directly or accessing S3 directly, so that that ephemeral cluster can do its job in a quicker amount of time. And so yes, the answer is you can run it separately, and it does dramatically help speed up these things for the ephemeral workloads as well as the long-running workloads.
Great. Our next question here is there a performance impact for using Transparent URI?
Yep, that's also a great question, I think. And so Transparent URI, like we covered in the slides, is a new feature in Alluxio that allows you to not have to create additional tables with Alluxio specific locations. And so the performance impact of that is actually pretty much none. It's actually handled at the client side, and you can think of it as essentially the same amount of overhead as what it would take to look up to see if a path exists, and if that path exists, to do some I was going to say string comparison, but that's the wrong word for it. It's going to be string swapping. You're essentially swapping out one string for another string. So the impact's extremely low, minimal, and it's not something that's going to impact the latency or the throughput of these workloads.
Great. And just a reminder, folks are welcome to submit their questions through the GoToWebinar control panel. Here we have our next question. What catalog service can I use for EMR Presto with Alluxio?
Great. That's a great question. So the typical catalogs that you might want to use, you can use with this configuration. And so one of the great things about Alluxio is that it's really agnostic, right, to the types of things that you want to use. You have the tools that you want to use for your workloads and for your requirements, and typically those tools in this space are going to integrate with Alluxio, and they'll integrate in different ways. But if you're trying to use a Hive Metastore, if you're trying to use Glue from AWS, both of those can be used quite easily as catalogs for Alluxio to either store data. The great thing is this kind of ties in with the Transparent URI. Part of the requirement for working is one of two things, right? Either in the catalog definition, you're pointing to an Alluxio URL, or you're using something like Transparent URI to swap out that for you. And so Transparent URI makes it completely seamless to the application. The application just continues using whatever catalog it was using before, and Alluxio is just swapping out the locations for you automatically. So you're free to use whatever works best for you.
Great. Next, here we have, can I configure this to connect to my data warehouse that is not in EC2?
Yes, you definitely can. So, if you've got, let's say for some reason you're running your warehouse and you've decided Google Cloud Storage is the best option for you, the answer is yes. Alluxio connects to a number of different storage systems. And so most of those are going to be around different variations of object or blob stores that might be running on the cloud or on premise. It connects to HDFS warehouses, it connects to NFS stores, and a couple other things. But anything Alluxio can connect to, you can run in this configuration. And so all that's really needed to do is you just need to do the proper work beforehand to set up the security groups such that they're going to allow connectivity on the ports and IPs that you need to actually connect to the data warehouse. And from there, you simply include that in the Alluxio configuration, and it'll be able to connect to and mount your data warehouse whenever the cluster boots up.
And a follow-up question here is, does this continue to work if I resize my EMR deployment?
Yeah, so EMR is unique in the Hadoop world in the sense that it gives you an easy way to shrink and grow the cluster. And so the answer to that is also yes, right? The Alluxio workers themselves store data, and we have the concept of a master that has kind of a layout of all the workers and all the data that's stored. And so the way the Bootstrap mechanism scripts work is they allow us to easily fire up additional EMR nodes, and when those nodes are fired up, the workers are installed on those nodes as part of the Bootstrap mechanism. And so when you grow your cluster, the EMR framework simply leverages the Bootstrap that was initially used, and Alluxio is just installed as part of that and automatically join those workers that automatically join the cluster. When you shrink the cluster, those workers automatically leave, and the data that was on them can either be replicated to other remaining workers in the cluster, or it can be fetched from the underlying data source if it's not available in one of those nodes. But yes, it works very well with the resizing functionality of EMR.
Fantastic. Those are some really great questions, and we're still available for a couple more minutes to answer a few more questions if there are any. But in the meantime, I want to take this moment to thank Alex for the really interesting presentation and cool demo that he's done here. And we'll be hanging on for a couple more minutes if you have additional questions. Even after the online office hour concludes, you can always reach out to us on the community Slack channel at alluxio.io/Slack, where Alex will also be roaming about.